Okay, we're going to be talking about homework B, or homework 2 part B, where we go over kind of the bounds for the crack Nicholas and why it wasn't constrained by the point 0.5 that we saw in the previous videos. So start out with, we want to get this in terms of our or our Tn plus 1 and our Tn. So we're going to go ahead and pull these out of both sides of the equation. So we'll have Tn plus 1, and then we'll have negative r, and then how previously, actually, hold on a sec, let me turn the light. Okay, so yeah, so we're gonna pull this out. We'll have negative r, and then previously how we solved for t, and we said that it was e to the I change in x and k, and we put that there because we pulled out from our j plus 1 value, so it's offset by 1t, so we go ahead and put that in there, and then we have r plus 1 minus 2r, and that just, we have no e here because that's just the normal j that we have, and then we're going to minus r, and then this will be e minus I because it's now back behind 1 from our original, or our target t. So we'll have I changed in x and k, and then this will equal, we'll pull out the tnj here, and it'll basically be the same thing, e I changed in x k plus 1 minus 2 r, and then plus r e to the minus I. Here, I'll put this down here, running out of room. So plus 1 minus 2r plus r e to the I changed in x and k. Okay, and then we have our Euler's identities up here again. We have e to ix equals cosine x plus I sine x, and then e to the negative ix equals cosine x minus I sine x. So if we were to plug these in here, we would end up with t, our sine x's are going to cancel out again, and we're going to end up with minus 2 cosine x. So we'll end up with, we'll move this back so we don't run out of room again. So t n plus 1 j is going to be r, negative r, cosine, or negative 2r, negative 2r cosine change in x k, and then we're going to have our plus 1 minus 2r, and then this will be equal to basically the same thing. We're going to have t j n plus 1, and we'll have our minus r to cosine change in x k plus 1 minus 2r. Okay, so this will be our new equation now that we accounted for our Euler's identities. So we can go ahead and divide these over, so we can have t j n plus 1 by itself, and this is going to be equal to t j n plus, or not n plus 1, it's just going to be n. And then we'll have, we'll factor out the 1 minus 2r, and we'll be left with, it'll be 1 plus 2r up top, because we're going to divide this over. So it'll be 1 plus 2r, and then 1 minus cosine of change in x and k, and then over 1 minus 2r, or add that backwards. It should be 1 minus 2r up top, and then it's going to be 1 plus 2r on the bottom here, and then we'll have 1 minus cosine of change in x k here. Okay, that's it. I had something wrong. So these should be pluses right here. That's why I messed up on that. So yeah, the 1 plus 2r will be down here at the bottom. We factor this out of the cosines. So that leaves us with 1 minus cosine change in x k, and so we know that cosine has to fall in between the bounds of -1 and 1. But otherwise, you have nothing really bounding it, and it will kind of just oscillate, and you won't get good numbers because the temperature will go to infinity. So what this does here, so with the 1 minus 2r, 1 plus 2r, that's going to be kind of our bounds right here. That's just going to keep our temperature bounded and give us temperatures that don't go off into infinity when it passes 0.5. So the 1 minus 2r plus 1 plus 2r keeps within our bounds of -1 and 1 because of, so if we say our r is 10, we'll have 20, 1 minus 20, which is going to be -19, and then you'll have 1 plus 20, which is going to be 21. So you'll have basically, this doesn't exceed 1, so you'll have 19 over 21, which is going to give you a fraction. It's not going to be more than 1 or less than -1. And that will be true for any number. So like you could put a 3 in there and you'll end up with -5 over 7. You know, it's still going to be in between -1 and 1, and that's just going to keep it from our amplitude getting out of control and having our numbers go to infinity. It also keeps our magnitude less than the previous one. So the change from j minus 1 to j is going to be less than the magnitude of change from this should be this one. From j plus 1, from j to j plus 1, the magnitude is going to be less than that from j minus 1 to j, because that amplitude value is going to be, or our r value is never going to exceed that -1 to 1. It's always going to be a fraction. So that's why we can exceed those bounds of 0.5 that we couldn't before.